Welcome back to the channel. Today we have 2026 Jan P3 walkthrough. It is Edmond. Don't forget to subscribe. All right, question 7. Question 7, you have a function f of x given by the modulus function of 3x minus 11 minus 4, and the graph is given here. Now the first question is to find the coordinates of P. P is the vertex point of the graph. Now you can see the question is state. That means they don't expect you to show any kind of calculation, but we need to understand that. Now for the vertex point of a modulus function, the y coordinate will always be this, will always be negative, will always be this value in this position. That will always be the y coordinate, and the x coordinate is when this function equals to 0, or what's going to be the x-intercept of the function inside. The x-intercept of the function inside, that means 3x minus 11 is equal to 0, so 3x equals to 11, so your x is 11 over 3. So the point P is 11 over 3 and minus 3. All right, the next part is f of x equals to 8. F of x equals to 8, that's part B. I'll write it over here. Part B, f of x equals to 8, that means 3x minus 11 minus 4 is equal to 8. That's part B you're trying to solve. Now, in this scenario, so I'm going to do it in a different way. I'm going to move the 4 on the other side. So I have 3x minus 11 is equal to 12. Now, how I want you to understand this equation, if they say that 3x minus 11 is equal to 12, it means that either the 3x minus 11 is equal to positive 12, or the 3x minus 11 is equal to negative 12, because the modulus function can be negative or positive. The original function can be negative or positive. So what we have here is a 3x equals to 23. That means your x value is 23 over 3, and from here 3x is equal to negative 1. That means your x is equal to negative 1 over 3. So your answers, you have two answers. X is equal to either 23 over 3 or x equals negative 1 over 3. That's part B. I'll erase this and then move on to part C. Let us see part C. Part C says that is a line. There's a line y is equal to mx, and that line y is equal to mx is a straight line, meets the function f of x at exactly 1 point. So for this part C, if the curve meets at exactly 1 point, the first culprit is this guy here, this point over here. That means the line should pass through that point. That's the first thing we think about. The line passes through that point, that is y is equal to mx. That means our f of x should equal to mx at that point. That means the point P should lie on the line m of x. And what's the point P? We know the point P is 11 over 3 minus 4. That means 11 over 3 and minus 4 should lie on the line y is equal to m of x. So this negative 4 equals to m into x, which is 11 over 3. That means your m is going to be negative 12 over 11. So this is the first possible value of m, but they say the possible values of m. But you see that this equation we have here, y is equal to mx, at this point, or that line is fixed at the origin. So the m can change, but the line is fixed at the origin. That means the line can pivot, but it's pivoting about m. It can go in any direction, but it's pivoting about the origin O. Now you can see one thing here is that if you keep on pivoting this line here just about the origin, is that this line is going to meet at 2 points until when this line is parallel, until this line is parallel to this one over here, to this part of the graph. Until when it is parallel to that part of the graph, that's when it will meet at only 1 point. But as long as it is still on this side here, it's going to meet at 2 points, and the gradient of this line is 3. That means when m is greater than or equal to 3, it's going to meet at exactly 1 point. So imagine this curve, this line going on to the other side. All along it is just pivoting at at this point here. But it's going to go up to infinity until when it's going to change until to infinity, until when it is a vertical line. It's going to meet at 1. And then when it reaches infinity, it's going to start from negative infinity. The graph can go all the way that side until when the graph is negative what? When it is negative 3 over here. When it's negative 3, it will not meet. That means even when m is less than negative 3. So we have three values. M is greater than 3, m is a negative 3, and m is equal to negative 12 over 11. Next part, part D of the question. Part D of the equation say that the graph of f of x is transformed by the function y equals to a f of x minus b. And then what happened to the graph is that the vertex, we know the vertex of the graph, the vertex was p, which was 11 over 3 and negative 4, was transformed to a new point, which is 5, 16. And we'd like to find the value of a and the value of b. So what we are going to ask ourselves is, how does point b change the graph? For point b change the graph, you are going to get all the x values and add the value of b. That means what we did, we got all the x values. So the x value is 11 over 3 plus the b, and the answer was 5. So when you solve your equation, you see that b is equal to 5 minus 11 over 3. So your b here is going to be 4 over 3. Now, what about the a? What happened? How does a affect the graph? For the a to affect the graph, what you're going to do, you're going to multiply all the y values by a. That means what they did, we got negative 4, and they multiplied it by a, and our answer was 16. That means our a was equal to negative 4. Those are the values of a and b. Thank you.